Hello everyone. Today I'm going to be sharing about application development for the wearable devices. My name is Mithu Danai and my student ID is 157. So there are many types of wearable devices such as sport watches, smart watches, and fitness tracker, and also headset. Wearable devices enhance our daily life by providing convenience and instant information, and also they are very useful for the health and fitness. So I'm going to tell you about how to design the wearable applications. Wearable applications should have the following features, just like voice commands and simple hand gestures, because they need to be easy and user-friendly. And also they have to display the small but important piece of information and deliver the timely notification as they have very small screens. And also they need to consume less battery and less memory usage because wearable devices are very small devices. So the application should have the following features. And also there will be challenges for the developers when designing the wearable application because they have limited screen size and limited battery and the memory usage. So the device compatibility is also important because wearable devices cannot stand alone. They have to connect to with the other device such as smartphone or laptop or computer. There are many operating systems of the wearable devices, such as Apple Watch OS, Tizen OS by Samsung, Wear OS by Google, and Apple Vision OS. These are the comparison between these OS, Wear OS, Tizen OS, Watch OS were released a decade ago, and the Vision OS was released this year, so it is very recent. And now I'm going to be sharing about the Apple Watch OS architecture. A watch application in iOS need three components: an iOS application, a watch case extension, and a watch application. iOS application is created using Quantum Visualizer and runs on the iPhone. And watch application display the UI elements and handle the navigation. A WatchKit extension consists of the application codes and additional resources and executes the watch application logics. Is bundled with the watch application and runs on the Apple Watch. These are the figures that describe the three components, how these three components are communicate with each other. So the next one will be the watch OS architecture. This is the figures that shows how well OS on Google or Android devices are communicated and connected. They are communicated using many APIs such as data API and Note API and Message API, and also they connected with the Bluetooth. So, so the one of the API is the Node API. Node API classes keep track of all the connected and disconnected nodes that have been established within the wearable network by using Node Listener interface method. And the following is the process of how the Node API works. And the next one will be the message API. Message API class is responsible for the sending short messages to each of the connected network nodes between the wearable and the smartphone. Once a message has been received, the receiving side uses the background listener service message listener to guess the message. The last one will be the data API. Data API class is responsible for syncing data between the connected Android wearable and the smartphone. The following process is the following process show how Zeta API works. So this is all about my part. The next part will be explained by my group member.
Hello, my name is Lemuel. So today I'm diving into the world of wearable develop apps development. So let's get started. Our first step is setting up development environments. Choosing the right platform is crucial. Whether it's Android Wear OS, Apple Watch OS, or another compatibility is key. So once you have chosen your platform, installing its necessary tools is next. Download your IDE like Android Studio for Android World and ensure all SDKs and debugging tools are ready to go. Now, configure your development environment. Set up emulators, configure SDK and APIs, and don't forget to install any plugin for enhanced development. Lastly, connect your devices and establish connections between your development environment and wearable devices. This is crucial for real-world testing. So, understanding platform specific APIs for accessing device features. Moving on to understanding platform specific APIs, sensor APIs allow access to accelerometer, gyroscope, and heart rate monitor data. Understanding data formats and calibration methods is crucial here. So, notification APIs enable handling notifications programmatically. You can display, dismiss, and interact with notifications from your wearable apps. Health and fitness API are essential for tracking metrics like steps taken or calories burned. They provide access to health sensor data for accurate monitoring. Lastly, customization and extension. Customize word faces and implement gesture recognition and voice command for personalized experience. Implementing core functionalities uh, tailored for wearable device. Finally, implementing core functionalities. Design your interface for small screens, focusing on readability and simplicity. Battery efficiency is crucial. Optimize consumption by minimizing background process and utilizing low power modes. Data synchronization ensures seamless communication between devices and companion apps, maintaining data integrity and security. Health and fitness tracking implement feature for tracking metrics like steps taken, integrating with health APIs for accurate data. And lastly, cross-device compatibility. Ensure your apps work seamlessly across various wearable devices, testing on different models and versions. This is the last part of me, and thank you very much.
Hello everyone. First of all, I just want to introduce myself. I am Shui Tong and my student ID is C531503182. Now I'm going to present to you sensor integration and communication with mobile devices for wearable devices. First, let's discuss some common types of sensors. Accelerometer. This sensor measures acceleration forces, allowing devices to detect movement, gestures, and orientation. Gyroscope. By measuring orientation and angular velocity, the gyroscope provides data for motion tracking and gesture recognition, enhancing user interaction. Heart rate monitor. Ideal for fitness enthusiasts. This sensor tracks exercise intensity, stress level, and overall cardiovascular health, offering insights into users' well-being. GPS. With GPS functionality, wearables can accurately measure distance, track routes for outdoor activities, and offer location-based service. Temperature sensors. These sensors measure ambient or skin temperature, providing valuable data on terminal comfort, detecting fever, and monitoring environmental conditions for health and safety. Now, let's explore how we can access sensor data and integrating it into app logic. Methods of accessing sensor data utilizing API or SDKs, developers can access sensor data efficiently. Integration into app logic. Integrating sensor data involves real-time processing, storage, and analysis, enabling developers to create meaningful user experience. and then implementing sensor-driven features. With sensor data at our disposal, we can implement a plethora of features such as fitness tracking, step counting, distance measurements, activity monitoring, sleep tracking, and stress detection, empowering users to lead healthier lives and enhancing the functionality of wearable devices. The next part is communication with mobile devices. First and foremost, we have the options of utilizing Bluetooth or Wi-Fi direct for seamless connectivity. These technologies enable devices to communicate effortlessly, ensuring a smooth user experience. Furthermore, implementing protocols like Bluetooth Low Energy can significantly enhance data transfer efficiency, crucial for transmitting information between devices while conserving energy. Moving on to data synchronization strategies, real-time synchronization is paramount to ensure data consistency across devices. By applying cloud-based storage solutions, we can centralize data management, facilitating easy access and updates. To prompt synchronization and updates, push notifications prove to be invaluable. These notifications serve as general reminders to users, ensuring that their devices are up to date with the latest information. Additionally, utilizing background services can streamline the handling of notifications and updates, ensuring that users are not disrupted during their interaction with the device. In conclusion, effective communication establishment is the cornerstone of wearable devices development. By leveraging technologies such as Bluetooth, Wi-Fi Direct, and Bluetooth Low Energy, and implementing robust data synchronization strategies and security measures, we can create seamless user experience that prioritize efficiency, security, and reliability. That's all for me, and thank you so much.
My name is Suyu Yuja and my ID is 6531503186. Now I'm going to talk about notification and alert system on the wearable devices. The main goal of these wearable devices is to deliver the notification timely without disturbance on the daily activities. So the notification and alert system is very important, and the notification is carried out by having wearable devices connected to smartphone through wireless networks such as Wi-Fi or Bluetooth. The notification is when it is received on your smartphone, it will be transferred through wireless network to be notified on the wearable devices, and users can edit their preferences on how they want to receive the notification on the application that connects the two devices. An alert system is done through vibration monitors and speakers through voice assistants such as Siri, Bixby, Amazon Alexa, and Google Assistant. Depending on the device, it can also be displayed on a small monitors or projected in front of the user, and users can interact with the device to respond or dismiss the notification. Moving on to the voice and gesture recognition, and it is done by inputting users' command through voice through the built-in microphones, and it can be done through voice wake-up such as commands like "Hey Siri," and then the voice is processed through the speech recognition algorithm, and it will be converted to text, which will be processed to carry out the command, and the output will be the execution of the command, such as setting up a timer or asking to play music. Next is gesture recognition, and gesture recognition is done through inputting from sensors, and the sensors will map out the different gesture in real time. Unlike voice recognition system, it needs to be speedy and takes lesser time than in voice recognition. So the algorithm will recognize when the gesture is done, the algorithm will recognize the different gesture, which has been trained through machine learning inputs, and the output will be the result of the gesture commands, such as pinching and dragging the screen to move the windows, or swiping the notification to remove from the screen. This is the end of our presentation. Thank you for your attention.